context and background on Apprenda, we're a platform as a service company focused on enterprise use cases. So we license our technology to some of the world's biggest companies who then run an internal PaaS platform for their cloud native and existing applications. And about 2 or 3 weeks ago now, we announced that we're going to be merging Kubernetes into our architecture, and it's one of the reasons that we're here. And part of the focus of the conversation is how do you reconcile these two worlds? How do you reconcile the cloud native net new application world with what is in the enterprise today? I worked at Morgan Stanley as a software developer, so I'm pretty familiar with what happens inside the four walls of an enterprise. And when you look at the traditional app architectures, they're not really aligned with what we're thinking about when we think about cloud, but they're going to be there and stay there. So the talk really focuses on a bit of that. There'll be some technical conversation from an architectural point of view on how we're looking at this from a platform perspective. And I'll invest a bunch of the energy of the talk around that so that you can understand where this sort of end state is going to go and what it looks like ultimately. But just a quick show of hands, how many people here are either a developer at an enterprise or have been some point in their past? Yeah, that's what I figured, right? The reason that we care so much about this topic is the number of hands that shot up here were almost everybody in the room. When you think about software development, there are a lot of things that we do individually on our own time or with small businesses that we may have started, but ultimately everybody's touched by enterprise software development. And what we care about from a company point of view and just philosophically is how does an enterprise adopt the newest technologies? And part of that adoption curve is based on how they anchor what they've already done with what they're going to be doing from a net new perspective. So I think it's important that we start with some facts. We have to understand what it is that that the world looks like. And like I said, part of the talk is really setting context for this specific problem. Fact number one is that existing investments in an enterprise aren't going anywhere. That includes applications that have been already written. One of our customers, to give you perspective, has 10,000 custom apps that have been built by that organization over the course of about 15 years. Those applications aren't going to disappear. They're not going to be sunset. A lot of the infrastructure they've invested in is going to still stay there. So the enterprise use case is one where there's a lot of anchor technologies that are going to exist regardless of what cloud native or net new is saying right now. Number two is that apps might be cloud native, but enterprises certainly are not most of them, right? I mean, we like to look to companies like Netflix who were born in the cloud. Ultimately, the way they think about architecture patterns, the way they think about IT is very, very different than an organization that maybe has been around for 50, 75, or 100 years and may have acquired 20 or 30 companies during that period and integrated their IT functions into their own. That amalgam of IT, that model that was really aggregated over that 20-year spread isn't something that's remotely cloud native, but it's not going to go away. So when we think about cloud native, we have to contextualize it a little bit and understand that what we're talking about is that some companies can afford to adopt cloud native wholesale from the beginning because they were born in the cloud, and that's just not the case for most organizations. And the other one is that most cloud native apps in the enterprise will likely depend on existing application workflows. It's very rare they're going to be built as a silo. You'll find that microservices and cloud platforms will power new applications that still have these dependencies. And the interesting thing about the dependency is that it immediately creates a problem for why we care about cloud native. We care about cloud native because it's fast, it's nimble, you can be very agile, you can scale things quickly, but you add a dependency to an existing system and that becomes problematic. It's no longer, from an architectural point of view, going to have those qualities for free. There's a lot of work that has to be done. Interestingly, you can think about this even in the last era. Does anybody know what one of the primary use cases for JDBC is in the enterprise? Communicating with things like CICS mainframes, right? So JDBC was built for relational database conversations, but you'll have drivers that let you communicate with mainframes as a data store, and that's what we use JDBC for. So the last era of technology still reached back 20 years, actually more. CICS mainframes were created about 50 years ago by IBM. So you think about that context, that the last era of computing still had this deep attachment from a dependency point of view with a very traditional architecture. So it's just the case that you're going to find that almost all these cloud-native apps will have very explicit dependencies. So what do we mean when we say traditional application architecture? What are these old apps or what do these existing apps look like fundamentally? It's stuff that we've all worked on in the past. You'll have your typical 3-tier app architecture. You'll have a UI tier, you'll have a business logic tier, you'll have a data tier. That data tier is likely communicating to relational databases and mainframes. And they have a couple of unsavory qualities, things that today we're trying to fix. One is that the apps themselves are monolithic. Forget about monolithic architecture for a second and just think about the deployment model. You typically deploy all of these components all at once. You can't really decompose them into functions because they weren't written for that, and the way that you do development and deployment isn't really conducive to this microservices concept. Second is that they have these very heavy dependencies. When we think about a container-based app, you spin it up quickly and you might spin it down quickly, but that's not the case if you have a WebSphere deployment that might take 10 minutes to warm up before the app can boot. or a scenario like where the app server is sitting there already, like IIS on the Windows side, and you deploy apps to it rather than spinning up the app server as a function of the application itself. So these non-volatile heavy dependencies are actually kind of interesting because they're problematic in the context of cloud native, since it doesn't really align. Third is that configuration tends to be very, very static. It's embedded with the application. It isn't something that you can control easily. Any concepts of what you might see on the 12-factor side simply don't exist in traditional app architectures. There's infrastructure specificity. The number of times that we bump into scenarios where people have still hard-coded things like localhost, right? Like that becomes problematic, or writing to the C drive. And that infrastructure specificity breaks most models that we see in cloud today. You can't really decompose deployability. Even if you wanted to break the monolith, there isn't an easy way to do it without refactoring the app itself in many cases. So suddenly you find yourself in this problem state where you really want to do some interesting things, but because you have a backwards dependency to the existing app, you can't. And last is that they're not very portable. A lot of these applications, because of the above, end up in a state where it's very difficult to say I'm going to move an application from point A to point B and get some sort of benefit because I'm changing infrastructure. So think of moving from on-premises infrastructure to something like AWS. And what you end up with is really, it's like a boat that went ashore, right? It's stuck. You can't do much of anything. You can invest a lot of energy to try and unlodge the boat and get it back in the water, but the amount of energy required to do that is very, very high. So you have to really think, what do you do? And what happens with a lot of these cargo ships is they just leave them. You can go around the globe and find a bunch of ships that are washed ashore like this, because getting rid of them is kind of complicated. So these enterprise apps, even if they were bad and you wanted to get rid of them, simply they can't go away. And they end up representing a lot of really core foundational workflows in most enterprises that these cloud native applications will need. So what do? There are three primary options that we see, at least with our customers. Number one is that you can decompose all of the enterprise apps into microservices. You can force cloud native patterns. But remember the scale that I talked about earlier. One of our customers has 10,000 custom apps. Another one has 4,000 custom apps. Usually you're talking about thousands and thousands of custom apps that were written over 15 years in .NET, in various Java app server flavors, whether it's JBoss or WebSphere. The idea that you can go back and refactor all of those is probably not realistic. So that's not an option that, from a pragmatic point of view, we think is reasonable. And most large enterprises aren't going to do that. Now, the reason this is so important is when we think about technology adoptability, we believe, at least, that enterprises really have to get behind a technology for it to become a mainstay, right? It's a skill set that drives a lot of the labor demand that we see, that creates the jobs that people want. So ultimately, enterprise adoptability is important. And if you go back and say refactor everything and they're not going to do that, then you end up in a spot where they can't really adopt cloud native. Option number two is to leverage some CI/CD tooling and platforms that might be able to support the various components. So you might have a platform that supports cloud native. Think of something like Kubernetes or GCE, and then you might have a platform that supports existing applications, and that could be something like Apprenda, at least that side of our platform, which we'll talk about in a little bit, and try to capture that in some sort of hybrid function through CI/CD tooling. That tends to be an okay model. It at least lets you deal with things like deployment and configuration in the context of a mixed app where you have both cloud native capabilities and existing app components all as part of one unit. So we're going to actually take a look at this option just through a quick demo. We wrote a demo that we're going to be posting to GitHub and plug in for Urban Code that allows you to exercise Urban Code workflows against Kubernetes and things like Apprenda. And again, it's a way to solve this problem, at least partially, in the context of app deployment and configuration. Now, when does this use case come up inside the enterprise? Well, as I mentioned a couple of times through the talk so far, we find that a lot of cloud-native apps have very explicit dependencies on existing applications. You might see something like one dev team building something in .NET, a back-end service that is backed by SQL Server, which might be a very chunky, traditional, monolithic application. And then maybe a Flask front end that's built by another dev team that's taking a bit more of a modern cloud-native view of the world, and it's communicating to that backend. So we've architected a sample application that captures what we think is a pretty realistic use case inside the enterprise, which is this composed multi-era application. This specific app that we're going to deploy through this CI/CD workflow has the front end written as Flask, and that's communicating to a couple of different Google services, talking to a web API-based .NET service that's using traditional SQL Server. And it might have other enterprise add-ons. For example, it might tie into your local auth system in a federated fashion, something like CA SiteMinder, or the type of things that you don't see in cloud today, right? The traditional enterprise identity systems. So what I'm going to do is actually show you that real quick. And the reason I'm going to show you is I want to show you that it is kind of simple to deal with this in a CI/CD fashion, but then we're going to talk about what the gaps are, and that's where things get kind of interesting in my opinion. So as I mentioned, we've got an Urban Code plugin that we created. And that Urban Code plugin has a fundamental understanding of things like Google App Engine, Kubernetes, Apprenda, and it can let you take multiple components for an application, and it'll decompose that project into the constituent parts and deploy the right component to the right cloud. So for example, if I go here to the application section of Urban Code, and I click the Google Hybrid App demo, and I look at the process that is being used in Urban Code, I'll see that it'll take a payload, a package that is the application itself. It'll understand which components are targeting something like GCE or Kubernetes, which ones are targeting Apprenda on the traditional .NET side, and accordingly supply the configuration and deployment for those subsystems and get the application pushed to those various clouds. Now, if I go ahead and deploy this, what you're going to find, let me select this, deploy target. What you're going to find is that it's a relatively low friction process. So from the perspective of an enterprise, you might think that the easiest way to handle these mixed era applications is to simply capture it in the CI/CD model and let that do its deployment work. Now, as I mentioned, we're going to talk about the various things that are gaps in this sort of architecture approach or CI/CD approach to solving the problem of existing apps with cloud-native apps. All it's really doing is handling the deployment function. And a lot of times when we think of platform as a service or any sort of cloud capabilities, we're always looking at the push side of things. How do we push an application to a cloud? And we've decomposed the problem of enterprise apps mixed with cloud-native apps as a deployment problem, but it's not really that. This will take about a minute or so to deploy. What's going on right now is it's pushing the Flask components to Google App Engine. It's pushing the .NET components to an Apprenda-based cloud, and it's going to run those side by side with a reverse proxy that lets them talk to each other. This is what we see often when we talk to enterprises when it comes to reconciling the two architectures. The idea is, let's solve this through configuration and deployment as opposed to solve it architecturally. This takes about a minute and a half. Now, what ends up happening is that we'll have an application up and running at this URL that is a composite app using both the front end and back end components. Now, it's just, again, a dummy application. So what's wrong with this model? Why is this problematic? Again, it provides a stopgap for certain types of applications, but it creates certain architectural flaws as well. So I'll bring that slide back up. And all you've solved is a deployment problem, but you're missing what we think are 5 pretty key things in any sort of architecture that is cloud-like, that is going to have a mix of existing application components and cloud-native. One is that it's missing sturdiness. If I add more components to that architecture, whether they're existing app components or new cloud-native components, I have to redefine what orchestration means. I have to go back to something like my CI/CD system and specify that here are new deployment targets, this is how I want you to handle them. It ends up being kind of brittle from a deployment perspective, and it suddenly creates a huge burden on a large enterprise who might have thousands of apps to constantly upkeep CI/CD and deal with things in that sort of fundamental way. Number 2 is that safety is missing. There's no policy enforcement. Again, that's dealing with just the deployment problem of taking an app that's cloud native and existing and not anything else. So how do you deal with security between the app components? How do you deal with any sort of runtime expectations, like how many instances of the app need to be up and running? It's a very passive model that simply pushes bits to servers. Third is that you end up with a lack of deterministic dependency behavior. Think of certain situations that we've seen in practice where you might have a cloud-native app that spins up in a couple of seconds and then a back-end written in WebSphere that, as I mentioned earlier, might take 10 minutes to spin up. Does it really matter if you can scale that front end very, very quickly if it takes 10 minutes to boot a new instance of this WebSphere component? Not really, because you'll outpace the front-end scale-out, in that case, or the cloud-native scale-out. When it comes to the back-end, that dependency going to the back-end suddenly becomes a weakest link, and you can only scale as quickly as the slowest component. So you have no way to deterministically have dependencies between two types of architectures and say, look, scale the cloud-native pieces only as quickly as the back-end pieces, because there's no point in scaling. You're going to bottleneck the system this way. So you're missing that. Last is fourth, you're missing dynamic runtime change awareness. What happens if a piece of infrastructure dies, right? In something like Kubernetes, we know that we'll suddenly get a new instance of that container hydrated someplace else. We can have minimum instance guarantees. Same is true in Apprenda. And you don't have any of that when you're solving this problem exclusively through deployment models, right? Pushing applications to various clouds through CI/CD systems. So you have no way to react to change in context. And last is that there's no easy way to share data between those components. If you have something that is containerized and you have an existing app that isn't, and they have some sort of common communication bus, how do you solve that through deployment? Again, CI/CD just solves the push problem. So what you end up having is this need to have a platform that kind of reconciles these two types of architecture patterns and brings them all under one operating system, data center operating system, for lack of a better word, to not just solve deployment challenges, but to solve these 5 challenges that you see in practice. And that's option 3. It's avoiding the, let's just solve everything through CI/CD, but instead actually capturing it in the context of a platform that understands mixed era apps. So when we announced our support for Kubernetes a couple of weeks ago, the focus was that. How do we create a single platform that acts as a data center operating system, that uses Kubernetes for cloud-native components, but also knows how to handle these complex workloads for traditional applications that are WebSphere-based, that are Windows-based, that might be JBoss-based. And that's our focus, which we think is actually a pretty happy option. So what I want to do is walk you through what that sort of Kubernetes-based architecture looks like, and this is how we're thinking about the world and how we're looking at Kubernetes support. So we're incorporating Kubernetes as part of this mixed mode model because as we started evaluating the various technologies for cloud-native capabilities around Docker specifically, we saw that there really wasn't a platform that could handle this sort of mechanical distribution of workloads the way Kubernetes does. And we decided to go with Kubernetes for 3 reasons. One is the technology. Just I think pretty fundamentally, everybody understands that when you have somebody that has the DNA that Google brought to the table to originate the Kubernetes project, it gives it a backbone that you can't find anyplace else. The community has been fantastic to work with so far. And last, the market's pretty interesting. When we have conversations with the large enterprises, the amount of interest in Kubernetes, I think, is unparalleled at this point compared to most other technology stacks. Now, before I get into the architecture that we're pursuing and understanding how we're trying to solve this problem of having existing app components and cloud-native components all under one platform, I want you to understand Apprenda a bit more deeply. So currently, as a platform, we do support cloud-native capabilities as well as existing apps, but we do that through direct Docker integration. We have our own scheduler. That scheduler is responsible for things like Docker-based deployments of non-Dockerized applications like IaaS-based apps on the Windows side or JBoss or WebSphere. We actually do a very good job at these heavy non-volatile app servers. Our scheduler is aware that in some cases we want standing instances of something like WebSphere that we place applications into instead of spinning up the entire app server along with the app itself. That sort of heavyweight model doesn't work too well. So we've built a scheduler that understands those mechanics and doesn't treat everything as container-based. We have very strong Windows support. And then last, or actually I just went over this, the scheduler does understand these warm and waiting servers that receive workloads. Now, our goal end state was how do we take those strengths that we have and replace and start enhancing our cloud-native capabilities to be Kubernetes-based so that we can truly give a single platform that solves that problem. Now, it's a busy architecture slide, but I want to walk through it. The colored components are new components that we're starting to build out in the Apprenda architecture to reconcile these two worlds. So I shaved off some of the Kubernetes traditional architecture that you see in the standard Kate slides, and instead I just focused on a node. But what we looked at was how do we reconcile the traditional Kubernetes node with these non-volatile nodes that are Apprenda native. These non-volatile nodes that we refer to are Apprenda's architecture pattern around these app servers like IaaS, like WebSphere, like JBoss, that has an understanding of these hot and active server instances that we start deploying apps into instead of spinning up with the application. Now, we had a couple of architectural goals that we think are important in solving this challenge. One is how do you solve the deployment challenge? Number 2, how do you solve the runtime challenge of allowing an app like this to execute side by side with other components that are part of the logical application that might be cloud native? And that meant bidirectional communication between cloud native components and existing app components. So working from the top, the way we view the world is that we, as a platform, currently ingest full composite applications. You don't give Apprenda just a microservice or just a Docker container. You give us an application that will an application package that will contain all parts of your functioning app. It'll have your relational databases, and we manage things like Oracle and SQL servers on the SQL Server instances on the platform. So give us your relational databases, give us your Windows services, give us your WebSphere EAR files, but then also give us your microservice targeted applications, your Docker containerized apps. That comes into Apprenda as a single package. We're building a decomposer that can fundamentally say, all right, I'm going to digest that package and infer from the package architecture which of these are traditional existing app components and which are components that are cloud native. That decomposer then takes those different components and allocates against the Apprenda scheduler. The Apprenda scheduler has its own scheduling tasks and capabilities, very similar to what you might see in Kubernetes, with affinity rules, minimum instant count rules, the ability to have kind of fit predictive models, that same exact pattern. But instead, we have to treat the existing app components in a way that we understand for the Apprenda native nodes. And then we map any sort of requirements for the cloud native components to the Kubernetes scheduler, which then defers that to the standard node structure on the Kubernetes side. So that's the application ingest part of the architecture. Next, we have to think about, once deployed, let's imagine that we have an application that does have a Windows service or a WebSphere EAR file and some sort of cloud native component landing on the Apprenda architecture. We have to understand bindings between those components. So if you do have a true composite application that has some part existing app, some part cloud native, there needs to be a binding model and a dependency manager that understands the configuration bindings that are necessary to allow those applications to talk to one another. And then second, the runtime expectations that are inferred by that dependency. We mentioned one earlier. Scalability doesn't really work if the boot time and warm-up time of one component is really, really slow and the other one is really fast. The scaling model breaks down. So the dependency manager that we're focusing on really reconciles those two worlds and understands how to deal with the discrepancy and the configuration between existing and cloud-native apps. Those will inject the appropriate configuration and the appropriate bindings into each of the models so that bidirectional communication can happen. Next is exposing those endpoints such that other services can consume them and they can communicate to one another. And we have effectively a common service catalog and proxy system that allows for co-registration with these very different types of architecture components. And that service catalog is something that's being built out to really understand both sides of the pattern and ingest the service and then expose it so that external agents as well as internal agents can communicate with it. And plugged into that is a shared base services catalog. Now, in the shared base services catalog, what we care about are things like shared caches or shared queues. You may make modifications to an existing app component to be a little more cloud-native friendly. And when you make those modifications, you likely want to use a common set of services and service bus that both cloud-native and existing apps would be using. So, simple example, in Apprenda, the backing cache for our caching model is Redis. So if we have Redis plugged in and we want to start exposing caching capabilities to both sides of the house, there needs to be a common registry that says, here are the platform services that are exposed and available to both the existing applications and the cloud native. If you don't reconcile that, then you end up with an architectural problem where you really can't figure out how do you get these two components to consume the same shared resources. So for us, the journey of incorporating and merging Kubernetes into our architecture is one that's really focused on trying to reconcile these two different eras, taking the cloud-native component era, taking the existing app era, and finding out where the discrepancies are between how you deploy, manage, and execute workloads that are a mix of both. And again, as I said at the beginning of the talk, the reason this is so important is that whenever we look at the enterprise use case and how enterprises consume platforms, it's very rare that they say, we can forget everything that we have. Let's just focus on cloud-native. It might happen sometimes, but as soon as that first dependency comes in that says, you know what, our cloud-native app needs to communicate to something that we do already, like an insurance claim workflow or a banking transaction, they're not going to rewrite that to be cloud-native. And that dependency suddenly pulls in all of these problems that we talked about, and you have to solve it. And the only two ways that we've seen in the field is something like, let's handle it through CI/CD, but we talked about the brittleness of that model. And again, it's an okay solution for now. But then the second solution is you need a platform that reconciles the two and thinks about the holistic application and the services that are necessary to accomplish that end state. So a lot of what we were going to be focusing on in the next few releases of our platform is solving these sets of challenges architecturally and making sure that we produce the right architectural components to tie all of these things together. Now, to do this, we're going to be participating in the Kubernetes community pretty aggressively in a couple of ways. One is that we're looking at how to simplify the post-compile time extensibility of the platform. Whenever we approach enterprises and we think about the existing app component use cases in Cloud Native, a lot of it is about extensibility of a platform, period. So when we're looking at the Kubernetes code base and we're thinking about how to start contributing, it's where can we build extensibility points and make it easy to allow Kubernetes to tap into some of the systems that you see typically. Number two is we're going to be spearheading the Windows support for Kubernetes. We really want to invest heavily in that. When we look at the Kubernetes architecture and we think about the enterprise use case, we start to see that in most enterprises, 30 to 50% of the workloads are still Windows-based. They're .NET, they're Windows services, and there's a lot of work that can be done both around existing Windows architectures as well as some of the new stuff coming from Microsoft like NanoServer that will allow us to incorporate those capabilities into Kubernetes so that the community has strong Windows support going forward. And for adoptability, we really do think that that is the ultimate end state, both on the cloud-native side, as I mentioned, with things like NanoServer, as well as the existing app components. And we're pretty excited about that piece. We think we can provide a lot of expertise over the years that we've built around Windows containerization and Windows app support and bring that back to the community. Third is enterprise readiness. When we deploy our technology inside the four walls of an enterprise and think about their data center, we're integrating with systems that have been built in the last 10 to 20 years. That number 3 bullet kind of plays into number 1. The extensibility of the Kubernetes platform will indicate how quickly you can incorporate subsystems and integrations with these enterprise solutions that exist today. And again, think of things like identity management or traditional queuing systems that aren't modern queues. How do you solve that problem when the enterprise isn't going to get rid of it? You really have to focus on extensibility and build the integrations necessary to make that easy to use from an enterprise perspective. So from the Apprenda point of view, when we talk about enterprise PaaS and how Kubernetes is going to play into it, the goal is how do we incorporate these 4 themes, these 4 threads, so that it becomes very easy for any enterprise to say, yes, Kubernetes is the technology of choice for us. And the reason that it's a technology of choice is that it aligns very well with what we've invested in today, and it also aligns well with the next 1,000 applications we're going to write in the next 10 years. And I think that's the answer for most companies. They really need to understand how a technology like this helps them with the things they've invested in, but also becomes the strategic platform going forward for that organization. So certainly look for our participation down these 4 vectors, and we're going to invest a lot of energy in that. That sums it up. I do want to open up for questions. I mean, they can be very technical. As I mentioned, I am a software developer, so we can get into pretty technical Q&A if you want, or also at the community level, just how these things might pan out. But any questions from anybody in the audience? Yep. Yeah, so the question was curious about service discovery for legacy applications. There are a couple of mechanisms for this, right? One, when we talked about our service catalog and proxy, part of the job of that cataloging and proxy function is to take things that are natively discoverable, arguably. Think of something like a SOAP service. When we deploy that, we register endpoints for HTTP load balancing. We can now also register those in a catalog that exposes them to any part of the platform, including the cloud-native components. What about things that aren't HTTP based? In that case, you can look at things like adapter patterns, and we've had a conversation, I think it's a bit of an open question internally, whether we allow exposing those components via service discovery or not at this point. I don't think there's a clear answer, but you could, for lack of a better term, register an adapter with a platform like this that says, here's a non-HTTP load balance component that is an existing app component. Here's an adapter that I would like the catalog to track and use to translate going forward, and that's the endpoint that gets exposed. Whether or not we do that and whether or not it's a high-fidelity solution is unclear to us right now. Any other questions? Yeah. So the first challenge is that there are 2 eras by default, right? When you look at NanoServer and a lot of the cloud-native stuff, it's very different than a traditional .NET stack, very different than anything that's traditional Windows kernel when you think about deployment and management of those. So I think the fact that it's a bifurcated stack immediately creates a challenge because they're not architecturally similar. And that dissimilarity means that we have to think about how do we not only reconcile Windows support in general with how Kubernetes does things, but how do we take the 2 eras of what Microsoft's created and bring those in the fold. So I think that's challenge number 1. I think challenge number 2 is that for the existing app stack, there isn't a clear container solution. We've built a bunch of things already in Apprenda that handles isolation, resource isolation, security isolation for things like traditional IIS. So I think number 2, it's how do we take those components that we've built and incorporate it in a container-like model that is exercisable in the context of Kubernetes alongside what Microsoft's doing for Docker and all the net new stuff. So again, it's kind of down that split fork road path that's the biggest challenge, but then when we get to the technical details, the containerization part is the one that jumps out most immediately. Again, there's a lot of tech that we've built that solves that, but now it's how do you retrofit that into a dual mode architecture like this. Great. All right. Thank you.